guys, so we're going to go over this today as the quiz review before tomorrow. Okay, so we have all these different types of functions. Okay, so let's scroll to what the actual questions are on the next page. So number 1 says compare functions 1 and 13. Which of these are even? Okay, so let's look at function 1 and 13. So 1's a little bit trickier because it is a equation versus 13 is a picture. So it's really easy to tell on the picture if it's an even function. Even functions are symmetric about the y-axis. So really that means like if I folded it along this y-axis, would it fold onto itself? And the answer is yes. So this is definitely an even function, okay, because it folds on itself on the y-axis. Function 1, however, the way you tell by a function is by plugging in like a negative for x. So, for example, okay, if I make this x a negative x, and then this x a negative x, and then I think about what the result would be, if it's the exact same, then that means it's an even function. And then if it is the exact opposite, like everything changes signs, then that means it's an odd function. Okay, so let's think about it. If we had negative x squared, negative x times negative x would turn into a positive. So this turns into positive x squared here, but that negative, I'm going to like drop that down. So it really just stays negative x squared. So that's good because, you know, if it's even, then that means it stays the same. But here in the second section, we have 8 times negative x, which is negative 8x. And so that's different because it started, and I'll drop down the negative 12. But that 8x started as a positive 8x, now it's a negative 8x. So it's not the exact same, which means it's not even. So this is not an even function. And you can kind of tell because this here is not, it doesn't have an even exponent, so that means it's not going to be an even function. But anyway, so it's just 13, not both. Okay? And the justification you can just write, that one folds over the y-axis, but the other one, number 1, it's not the exact same when you plug in a negative x. Okay? All right, number 2 says, which function has a greater maximum, 1 or 12? Okay, so let's see, 1 or 12. So 12, you can see the maximum is here, that the highest point is 2, like up at 2. So that's the highest. So we need to see what the maximum is for number 1. So we learned how to do that. So to find the maximum for number 1, you have to do negative b over 2a. Okay. So let's do that to find the x value of the maximum. So if we did negative b, that would be negative 8 over 2 times a. A is negative 1. So that's negative 8 divided by negative 2, which is a 4. So that's the x value of your maximum. And then to find the y value, because that's really what we care about, is how tall it is, right? So to find the y value, you have to plug in a 4. So I'm going to bring up my calculator. I'm going to plug in a 4 to that. Let me erase this. This was from the last video. Let me clear that out. So we'll do negative 4 squared plus 8 times 4 minus 12. Okay, and we get 4. Okay, so we have the 0.44. So the highest that one goes is 4, and the highest that one goes is a 2. So obviously number 1 is going to go higher. Okay, so number 1 goes higher. Justification, it goes higher, right? It goes to 4, the other one goes to 2. Okay, number 3 says, which function has a greater average rate of change from 1 to 3, 6 or 10? So 1 to 3, remember, those are your 2 x values. This is like x1 and x2. It gives you your x values. Sorry, guys. What was it? Function 1 and, or no, 6 and 10. Okay, so let's look at function 6. Okay, so it says 1 to 3, right? So those are our x values. So we need to essentially plug those in to find the y values of our coordinates here. So let's go ahead and plug in a 1 and a 3, and you're going to plug that in for every single x value. So we're going to do 1 to the 4th minus 4 times 1 to the 3rd, right, plus 4 times 1 squared minus 2. Okay, so we get a negative 1 when we plug in a 1. So this one is -1. And then let's plug in a 3. So I'm just going to copy and paste this, and then I'm going to change all those 1s to 3s. Plug in a 3 right here. Oops, plug in a 3 right there, and plug in a 3 right here. Okay, and we get a 7. Okay, and so then from there, you can just do the slope formula, which the slope formula, or the average rate of change formula, is the same as slope. It's just y2 minus y1 over x2 minus x1. Okay, so we'll do, this is x1, this is y1, this is x2, this is y2. So we'll do y2 minus, and just be careful when we're minusing a -1, you kind of put it in parentheses like that. So y2 minus y1, x2 minus x1. And what happens up here when we have a double negative, it turns plus a positive. So really that's an 8 over a 2, which is a 4. Okay, so the average rate of change for number 6 from 1 to 3 is 4. Okay, what was the other function they wanted me to do? 10. Okay, so let's look at function 10. And they want me to do from 1 to 3, right? So this one's a little easier off a graph. So I'm just going to go to where x is 1, which is here, and go up to the graph. So we have this point here. And then same thing, I'm going to go to where x is 3, go all the way up. It's kind of hard to see, but I think it's up here. Okay, and for that one, I am going to just count rise over run. You can do y2 minus y1, x2 minus x1, you get the same answer. But on a graph, it's really easy just to count how much you rise, how much you run. So I rise up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you go over 2. So that's a rate of change of 6, an average rate of change of 6. So that's definitely greater. Is that what it asked? Which one has a greater? So number 10 definitely has a greater rate of change. It has a rate of change of 6 versus the other one is a 4, right? The other one was 4. Yeah. Okay. All right, number 4. Okay, so number 4, you guys go ahead, and if you printed it, this is already changed, but if you didn't, and you're just watching the video, I'm going to do function 2 and function 6. Okay, so it says, which following has the end behavior as x goes to infinity, f of x goes to infinity, as x goes to negative infinity, f of x goes to infinity. So this is talking about the right side of the graph and the left side of the graph. The positive is the right, the negative is the left. And both sides are going up to infinity. So this one's pretty easy. You just have to know which ones are going up, both going up. So function 2 and function 6. Okay, so for function 2 here, hopefully you guys remember, it's been a while, but x to the third equations, I don't know if you guys remember this from first semester, but functions that have an odd exponent in the front there, that means the ends are going to go opposite directions. And because it's positive, that means the right side is going to go up. So it's going to be something like that, to where the right side's going up, but because it's an odd function, the other side's going to be going down. So that one, they're not both going up, so that's definitely not the answer. And then function 6 here, this one has an even exponent in the front. So even exponents in the front mean that the ends are going to go in the same direction, and because it's positive, that means both of the ends are going to be going up. There's probably some like loops and stuff in there, but all that really matters is that both ends are going to be going up. And if it was negative in the front, that means both ends would be going down. But this time, they're both going up, so that would be the answer. Okay? All right, number 5, it says, which function has an average rate of change that is increasing on the interval -3 to 3? Okay, so function 5 and function 7. -3 to 3, it needs to be increasing. That's all we need to look for. We don't even actually really have to calculate it unless it's a function. So 5 and 7. So 5 is here and 7 is here. Let me use black, 5 and 7. Okay, so it says from -3 to 3 that it's increasing. So let's just look at the table first because I think that's easier. So that's the entire table, -3 to 3. And so we just need to make sure the values are going up, and they are, right? -1, 1, 3, 5, 7, 9, 11. So this is definitely increasing, right? And then let's see, number 5. I don't know if you guys remember, this is a exponential decay, right? It's a decay because, well, it's an exponential because it has an exponential x. It has an exponent that's an x. I can't talk. But it's decay because it has that 1/4. And so exponential decays go like this. And you guys, you can always use Desmos if you don't have a graphing calculator. You could always use Desmos to graph these. And this one is going down like that if you graph it. And so this one is definitely not increasing from -3 to 3. Okay, so the only answer here would be function 7. That's the only one that's increasing from -3. Function 7. That is increasing from -3 to 3. Okay. All right. It says, which function has a constant rate of change, 4 or 14? So constant rate of changes are for linear types of graphs, okay? So we need to see which one's linear, 4 or 14. Sorry, 4 or 14. So 4 is linear, so like y equals mx plus b, those are linear. So that's definitely has a constant rate of change. And then 14 is definitely not a constant rate of change. This is an exponential. Exponentials don't move very barely at all from here, but then this goes up really fast. So that's definitely not a constant rate of change. So the only one that has a constant rate of change here is 4 because it's linear, right? Okay. Number 7, it says, which function has one root, 3 or 14? So root just means like solution, which means x-intercept. So it's really asking which one has one x-intercept, 3 or 14. Okay, so let's look. 3 is an ln equation. And so remember, ln equations have vertical asymptotes at whatever this number, the opposite of that. So if you kind of drew a little sketch, or like I said, use Desmos to graph it, you know, you would have a little vertical asymptote at -1, and then because it's a negative, it means it would start up here and go down, something like that. So that one would cross the x-axis, so it would have one x-intercept. Okay. So number 3, yes. What was the other one? 3 and 14. Let's look at 14. So 14, you see it doesn't even cross the x-axis, right? So that means it doesn't have any x-intercept. So the only one that has an x-intercept is the first one, okay? All right, next one says, what is the average rate of change of each function on the interval 2 to 6? Okay, so another rate of change problem. So function 4 and function 15. Oops, I keep going the wrong way. 4 and 15. So 4 is actually really easy because this is a linear function, and linear functions have the same rate of change. So you could take those x values and plug them in, do y2 minus y1, x2 minus x1, but you don't have to. This has a constant rate of change, and the rate of change is just the slope, which is this number in front of x. So the rate of change for function 4 is 1. Okay, so let's look at 15. 2 to 6. Okay, so these ones, I like these ones where it has a graph. Okay, so it wants me to go from x is 2 to x is 6. So from x is 2, that's here, up at 4. And then at 6, we're up at whatever that is, 5. And so to find the rate of change, we just do rise over run. So we could, like I said, do y2 minus y1, x2 minus x1, but it's easier just to count if you have a graph. So we're going to rise up 1, and we're going to go over 1, 2, 3, 4. So we're going up 1 over 4. So the rate of change is 1 over 4. Okay? So it says, what is the average rate of change of each? Okay, well, so that's it. 1 and then 1/4. Okay, let's try to at least finish the next few. This says, which function has a range of negative infinity to positive infinity, 6 or 11? Okay, so 6 is this. So that one is not going to have a range negative infinity because we already talked about how both the ends on this are going to be going up. And so since both the ends are going up, that means there's no going down to negative infinity. So that definitely does not have negative infinity, positive infinity. Okay, let's look at the other one, 6, 11. Okay, let's scroll to 11. So this one does. So you can see that this side goes down to negative infinity. This side goes up to positive infinity. So this does have a range of negative infinity, positive infinity. So it's definitely B there that has that. Okay. It says, what is the maximum minimum value of each function? Specify if it's a minimum or maximum. I don't think I'm going to have time to finish this on this video, so go ahead and go to the next video to finish this review. Okay, you guys, so continuing on, number 10, it says, what is the max/min value of each function? So 12 and 13. So function 12, we kind of already talked about what the maximum was for 12. So 12, that is a maximum, right? That's the maximum it goes, and that's at 2. So 4, 2 is the point. So this has a maximum of 2. Okay, and then number 13, or not number 13, function 13. This is definitely a minimum value, right? So this is a minimum value, and that's down at -1. So this is the point 0, -1, and then this one was the point 4, 2. But when it's asking about maximum, most of the time it wants to know about like the actual y value. So the maximum that goes is 2, and then the minimum this one goes is -1. So let me fill that in. Min of -1. Okay? All right, 11 says, which function has a domain negative infinity to positive infinity? 4 and 15. So let's look at function 4. So function 4 is linear. So remember, linear lines, this one is a positive linear line, so it's going to be something like that. And so that one goes in forever in both directions. And I mean, even if it was negative, it would go forever in both directions. So that is negative infinity to positive infinity. So this one, number 4, definitely is, let's see, if 15 has negative infinity to positive infinity, function 15. This one does not go because like you can see like there's nothing going over here to the x values that are negative. So this one definitely does not have negative infinity to positive infinity. So it's just function 4. Okay? All right, last page. It says which function is odd, 2 or 9? So function 2. So remember for these ones, for like the actual functions, don't just look at like the highest exponent. That's not really how it works. You have to plug in a negative and see if everything switches signs. So if I plug in a negative to all these x's, okay, you can already tell that that 48, there's no way it's going to switch signs at the back because it's just plus 48. And also you can see here this 11x squared would change to positive 11x squared, right? Negative x squared would turn positive. So this would stay positive x squared. This would stay positive 48. These would switch signs, right? That would change to negative 40x, and this would change to negative x to the third, because when you raise something to the third, it stays negative. But everything didn't switch signs, so that is not odd. So this is not odd. So don't just look at that highest exponent and be like, oh, it's odd. That's not really how it works. If it has even exponents, it's not going to be odd. So anyway, that's not odd. And then let's see. What else? Oh, we're here. So that one's not odd. And then function 9, let's see. Function 9. So that one is odd. Okay, so if you guys I mean, hopefully you guys can just tell that this is like rotational around the origin, to where like if I took this piece here and I like spun it around the origin, it would land on top of this piece here. And so that's what makes something odd. Like that's how you can visually see it. But you could also just kind of look and see if it has the same point like reversed. So like you guys see how it has the point here 2. It's really hard to see when this isn't printed, but I think it's 2, -7. And it also has the point -2, +7, right here. And so like that kind of indicates it as well, that it has the same point, but just signs reversed. 2, -7 versus this is -2, +7. It's the same point but reversed. So that one is odd. So number 9 here is odd, and then the other one is not. Okay. 13 says, which function has the following end behavior? So this one, this time, has a right side. Remember, x is positive, means right side. That's going up. And then it has a left side that's going down. Okay, so we need a right side up, left side down. So let's look at functions 7 and 9. So 7, let's see, if we kind of like graphed it, we have -3, -1, and then -2, +1, and then -1, +3. So you can see that it's going like this, right? It's just going up like that. And so the left side is going down and the right side's going up. Is that what it wanted? Right side up, left side down. So yep, so this one has left side down, right side up. So that's good. Okay, and let's look at function 9. So left side is going up on this, and then the right side is going down. So I think it wanted the right side up, and the right side here is going down. So this one is not, because the right side's going down instead of up. It's backwards. Okay? All right, 14 says, which function has no minimum, 5 or 8? Let's see. Okay, so number 5, so that one doesn't really have a minimum. So this is, we already talked about function 5 is an exponential decay. And it has this asymptote here at -2, if you guys remember, at y equals -2 to be more specific. So it doesn't really have like a minimum point. It like gets closer and closer to that, but it doesn't really have a minimum. Okay, so let's look at function 8. We haven't looked at that one yet. So function 8, this one is a little bit tricky, guys. This one looks like it's just linear because it looks like it's just going down, but it's actually quadratic. And the way you can tell something is quadratic, if you look to see like how the numbers are changing, from 48 to 35, we're subtracting 13. From 35 to 24, we're subtracting 11. From 24 to 15, we're subtracting 9, which we're not subtracting the same thing, so that's not linear. If it was linear, you would be subtracting the same thing, but we're not. And so this one this time, actually, if we look at the second difference, you see how from 13 to 11, we'd be adding 2. From -11 to -9, we'd be adding 2. So if the second time it's the same, that means it's quadratic. And so this is going to be a quadratic that obviously starts up at 48, goes down, and then it will have to come back up at some point. So this one has a minimum value. I know it's kind of tricky, but number 8, function 8 does have a minimum. Oh, it says which one has no minimum value. So 5 doesn't have a minimum value, but 8 does have a minimum value. Okay, so that one's a little bit tricky. But anyway. All right, 15, it says which function has more than one root? So that just means more than one x-intercept. Okay, so 4 and 13. So 4, that's a linear. That's just going to cross 1. So this only has one x-intercept. Okay, and what was the other one? 13. 13, 13. And so 13, you can see it clearly has 2 x-intercepts, right? So number 13, or function 13, has more than one x-intercept. Okay, 16 says, which function has a restricted domain, 7 or 15? Okay, so let's see. Function 7 is just a linear, I think, so that one just has no restriction. So this has no restriction. It just goes forever in both directions. You know, I swear I have short-term memory loss. I already forgot the other one. 15. 15. This one does have a restriction on the domain, right? Because it has this asymptote here. So that means it doesn't go back here at all. So that one does have a restriction. So it says which one has a restricted domain? The answer would be 15. Okay, 17 says which one has a restricted range, 1 or 9? Okay, 1 or 9. So you can see, I'm going to start with 9 because it's already graphed. So 9 does not have a restricted range. It goes down forever, and then, or this side's going down forever, and this side's going up forever. So it has a range of -infinity to +infinity. Versus number 1, so number 1, remember, whenever you have an even exponent in the front, that means the ends are going to be going in the same direction, and because it's negative, that means they're both going to be going down. So we're going to have both ends going down like this. It'll be like a parabola like that. And so the range doesn't go up. So this one does have a restricted range because it doesn't go up, right? It only goes down. So function 1 has a restricted range. Okay? All right, almost done. 18 says which function has an odd degree, 7 or 12? Okay, 7 or 12. So 7 is a linear function, and just to verify, like I know I just kind of assumed it was linear just by like graphing it, but you can verify it's linear by seeing that you add. You see how we're adding 2 every single time? So that just means it's linear. So a lot of times people assume linears are odd, and linears can be odd functions. But remember, odd functions are symmetric around the origin, and so it would have to go through the origin. And so you can see from us just graphing this off to the side here that that clearly does not go through the origin. So that is not an odd function. And I know it kind of seems like it would be because linears have an odd degree. And if we actually wrote this equation, it would be 2x because that is the slope here. And then plus 5 because that's where it crosses the y-axis. So 2x plus 5. And so really it only will be an odd if this number here is a 0. And since it's not, then it's not an odd function. Okay? Anyway, and then what was the other one? Function 7 and 12. Okay, 7 and then 12. And 12 is clearly not odd or even. It's neither, right? So actually both of these are neither. So I'll just write neither off to the side, I guess. So neither is odd. Okay. All right, 19 says, which function has the following end behavior? So remember, positive infinity means right side. Negative infinity means left side. So they want the right side to be going down, right, negative infinity, and then they want the left side to be going up. So the right side down. Let's just stick to right side down. So function 3 and 14. Function 3. So they want the right side to be going down. So this one is, the right side is going down. But I can't talk. ln functions are a little bit different with their end behavior because the x values don't actually go to negative infinity. So really the end behavior for this would be written as x goes to negative 1, not as x goes to negative infinity. So that one definitely does not fit that. Okay, so let's see, what was the other one? Go one more page. 14. Okay, 14. So 14 said they wanted the right side going down, right? So the right side is also not going down for this one. The right side is going up, so it's definitely not that one. So this one is a neither situation as well. So this one is a neither. Which function has the following end behavior? Yeah. So just be careful. I think that most people would have probably put number 3 just because they saw the right side going down and the left side going up. But remember, the left side doesn't go to negative infinity for ln functions. So be careful. It would have had to say as x goes to negative 1. So, be careful for ln and log functions. Okay? All right, and then last it says 20, choose any two functions and compare all the following characteristics: the domain, range, end behavior, even, odd, average rate of change, min, max, or roots. So I'll actually let you guys do that by yourself. I mean, we kind of already went through and did that for all of the functions, but you guys can choose any two functions and just kind of write down all those different key features. I'm not going to do it for every single function, but it would be good practice for you guys. And I don't know about the other teachers, but I will be having a live session. So if you need help with doing any of those characteristics for any of the functions, then, just let me know. And I'm sure if your teachers are not having a live session, then you can just message them or something like that if you have any questions. Okay, so I know this was a lot of information. Hopefully we knew a lot of this information already, but it is a lot of information. So, study it, make sure you know it, and then good luck on tomorrow's quiz.